Hello everybody and welcome to my channel Junior Astrophysicist. So recently there has been a groundbreaking discovery in the field of astronomy and astrophysics made by Nanograv. So Nanograv is an observatory that is dedicated to recording low frequency gravitational waves. They do this by observing pulsars. So Nanograv has been involved in this since 2007. They have been observing millisecond pulsars for the past 15 years. And finally, last week, they were able to make amazing progress. They were able to record the sound of low frequency gravitational waves for the first time in the history of astronomy. So how did they do this? Well, before I tell you how they did that, let me run you through a basic course of what we just spoke about. Let me start off by telling you what gravitational waves are. Okay? Now, for the concern of better understanding and better visualization, we are going to consider the four-dimensional space-time as a fabric. Okay? So the four-dimensional space-time is a combination of the three-dimensional space and the one-dimensional time. Okay? Now let's say this is a fabric, like a simple cloth fabric. And let's say I'm placing a kind of mass, a big ball on top of it. What is going to happen? The fabric is going to curve, alright? It's going to bend over. And we call this curving as the space-time curvature because that mass causes a curvature in the fabric of space-time. Now what are gravitational waves? Now let's consider a water body to be that fabric just for this case, alright? And now let's say I'm dropping a ball inside the water. What happens? From the place where the ball falls inside the water, from the place that it meets the surface of the water, there are small ripples that go around it, okay? It goes the outer way from the ball. So these ripples, in the case of the space-time fabric, is what we call gravitational waves, okay? Now let's move on to pulsars. So pulsars, in simple terms, are rapidly spinning neutron stars. Okay? Rapidly spinning neutron stars. Now what are millisecond pulsars? So there are these pulsars, okay? These pulsars spin very rapidly and the duration of one spin can vary from milliseconds to seconds. So the millisecond pulsars have a duration of one spin from about 1 millisecond to 10 milliseconds. And that's why it is called a millisecond pulsar. So in this universe, pulsars are the most precise cosmic clocks because they radiate pulses at fixed intervals without any change. So they're the most precise cosmic clocks in the universe. And that is why Nanograv chose millisecond pulsars to observe so they could record gravitational waves. So what they did was they started recording the times of arrivals of the pulses from 68 millisecond pulsars in our galaxy. Okay, there were 68 millisecond pulsars that they recorded in the past 15 years. So gravitational waves have very big wavelengths, okay? The distance between two crests can be in the count of light years, many hundreds of light years. And the frequency of these gravitational waves is very, very less, okay? So now let's say there is a pulse being emitted from a pulsar. And now we are predicting the arrival time of that pulse to Earth through some Nanograv observatories. What happens is, let's say we have a certain predicted time. But because of the interruption of gravitational waves on the pulses, there is a very, very, very minute delay in the arrival time of that pulse. The reason this is very minute is because the frequency of gravitational waves is very less. Okay? So there's a very small delay in the time of arrival of these pulsars. But that cannot be possible, right? If there are no gravitational waves, because pulsars are the most precise cosmic clocks. the pulses are emitted at fixed intervals. So in case there is a small delay, it has to be due to some kind of unknown reason. And in this case, gravitational waves. So now, by using their past 15 years data of observations and how the gravitational waves have been interrupting the emission of the pulses and the time taken to reach Earth, Nanograv was able to record the hum or the sound of gravitational waves for the first time, and in specific low frequency gravitational waves for the first time. Although we have recorded the sounds of low frequency gravitational waves, we are still not very sure about the source of these gravitational waves. We don't know where they're coming from, but we do know one thing though, that they are interrupting the pulses emitted from pulsars that reach Earth. And that is why there's a small delay in the count of the cosmic clocks. And that is how we were able to find that sound. This is a big achievement for Nanograv and for the entirety of the astronomy and astrophysics community. Thanks to Nanograv for making this possible. If you liked all of this information and if you like the content and the video I made, please show some support by subscribing to the channel and liking this video. Please let me know your feedback in the comments, and if you have any questions, feel free to ask me in the comments. I'll be replying. Have a good day, guys. Bye.